Okay, now this topic, HTTP, in which this stands for Hypertext Transfer Protocol. We have the following learning outcomes that by the end of this module, you should be able to describe how a web client talks to a server and how data is transferred from the server back to the client. Another outcome is to apply the HTTP application protocol to access documents and files stored on a web server. HTTP is a protocol for fetching resources such as HTML documents. It is the foundation of any data exchange on the web, and it is a client server protocol, which means requests are initiated by the recipient. Usually, the recipients are the web browsers. A complete document is reconstructed from the different sub-documents fetched, for instance, text, layout description, images, videos, scripts, and more. Clients and servers communicate by exchanging individual messages as opposed to a stream of data. The messages sent by the client, usually a web browser, are called requests, and the messages sent by the server as an answer are called the responses. Now, the Hypertext Transfer Protocol is a standard that defines how a web client talks to a server and how data is transferred from the server back to the client. Although HTTP is usually thought of as a means of transferring HTML files and the pictures embedded in them, HTTP is data format agnostic. It can be used to transfer TIFF pictures, Microsoft Word documents, Windows, exe files, or anything else that can be represented in bytes. To write programs that use HTTP, you'll need to understand HTTP at a deeper level than the average web page designer. This topic goes behind the scenes on showing you what actually happens when you type the URL www.google.com into the browser's address bar and press return. The protocol of the HTTP is a standard for communication between web browsers and web servers. HTTP specifies how a client and server establish a connection, how the client requests data from the server, how the server responds to that request, and finally, how the connection is closed. HTTP connections use the TCP/IP protocol that data transfer. So for the data transfer, it uses the TCP/IP protocol. And for each request from client to server, there is a sequence of four steps. The first step is the client opens a TCP connection to the server on port 80. By default, other ports may be specified in the URL. The client sends the message to the server requesting the resources at a specified path, which is the step number 2. The request includes a header and optionally a blank line followed by data for the request. And this is depending on the nature of the request. Now, the third step is the server sends a response to the client. The response begins with a response code, followed by a header full of metadata, a blank line, and the requested document or an error message. The last and the fourth step is the server closes the connection. So this is the basic HTTP HTTP 1.0 procedure. In HTTP 1.1 and the later version, multiple requests and responses can be sent in series over a single TCP connection. That is, steps 2 and 3 can repeat multiple times in between steps 1 and 4. Furthermore, in HTTP 1.1, requests and responses can be sent in multiple chunks. So this is more scalable. Each request and response has the same basic form: a header line, an HTTP header containing metadata, a blank line, and then a message body. And this shows a typical client request looks something like this. The GET request, like this one, do not contain a message body, so the request ends with a blank line. The first line is called the request line and includes a method, a path to a resource, and the version of HTTP. The method specifies the operation being requested. The GET method asks the server to return a representation of a resource. The index.html is the path to the resource requested from the server. HTTP 1.1 is the version of the protocol that the client understands, although the request line is all that is required. A client request usually includes other information as well in a header. Each line takes the following form: that we have the keyword followed by colon and the value. Keywords are not case sensitive. Values sometimes are and sometimes are not. Both keywords and values should be ASCII only. If a value is too long, you can add a space or tab to the beginning of the next line and continue it. Lines in the header are terminated by a carriage return line feed pair. The first keyword in this example is user agent. This user agent lets the server know what browser is being used and allows it to send files optimized for the particular browser type. And say, for example, we have the line that says the request comes from the version of 5.0 of the Mozilla browser. All but the oldest first generation browsers also include the host field specifying the server's name, um, which allows web servers to distinguish between different named hosts, um, hosts served from the same IP address. The last keyword is the accept, which tells the server the types of data the client can handle. Though servers often ignore this. For example, um, the lines says that client can handle meme media types corresponding to HTML documents, application, of a XHTML plus XML files. Other accept um, keyword like um, HTML documents, plain text, and JPEG and GIF images. Now, for the mem types, mem types are classified as the two levels. Okay, we have the type and the subtype. The type shows very generally what kind of data is contained. Is it a picture, text, or movie? The subtype identifies the specific type of data. GIF image, JPEG image, the IF image. Now, for example, the HTML's content type is text slash HTML. The type is text and the subtype is HTML. The content type for JPEG image is image slash JPEG, and that is the type is image and the subtype is JPEG. Now, there are 8 top level types that have been defined. We have the text for human readable words, image for pictures, model for 3D models such as the VRML files, audio for the sound, video for moving pictures, possibly including sound, application for binary data, message for protocol service, envelopes such as the email messages and HTTP responses, multi-part for containers of multiple documents and resources. Each of these has many different subtypes. And the most current list of registered meme types is available in the iana.org. Now, flash files are commonly assigned the type of application slash x dash shockwave dash flash. That is in addition to with the non-standard custom types and subtypes can be freely defined as long as they begin with x dash. Now, the first um or once the server sees that blank line, it begins sending its response to the client over the same connection. The response begins with a status line, followed by a header describing the response using the same name and value, okay, which specifies the syntax as the request header, blank line, and the requested resource. And this shows the typical successful response. This first line here indicates the protocol the server is using, and that is HTTP 1.1, followed by a response code of 200 OK, and which is the most common response code, indicating that the request was successful. The other header lines identify the date the request was made in the server's time frame, the server software, which is Apache, and a promise that the server will close the connection when it's finished sending, the meme media type, and the length of document delivered, not counting this header. Now, we have a table here which lists down some of the standard and experimental response codes you're most likely to encounter. And this shows the code and message, meaning, and the HTTP URL connection constant. 100 codes are informational, like 100 continue is means that the server is prepared to accept the request body and the client should send it. 101 switching protocols code means that the server accepts the client request in the upgrade header field to change the application protocol. Now, the other um, HTTP response code will be given as an activity in 6.3 item in LMS. That is, you can use the internet resources to look for the HTTP response codes. And you can choose at least one code and message to be submitted in 6.3 item. Samples of HTTP response code are given in the previous slide and also are given in 6.3 item in LMS. Please be noted that no duplicate of code and message. Meaning if there are already um, code and message sent with 100 continue, meaning you cannot submit that code and message anymore. Now, um, this is regardless to version. A response code from 100 to 199 always indicates an informational response. The code 200 to 299 always indicates success. 300 to 399 always indicates redirection. 400 to 499 always indicates a client error. And 500 to 599 indicates a server error. Now, the connections of keep alive and the HTTP methods will be given in the next video discussion.